Okay, in this video we're going to be discussing terms from sections 6.5 through 6.7, terms related to calorimetry and enthalpy. You may remember the terms from Chem 110 or whatever previous chemistry you may have taken, exothermic reactions and endothermic reactions. So let's review those terms. An exothermic reaction, heat is released. The heat quantity is written as a product. And a type of reaction that's an exothermic reaction is a combustion reaction. Okay, so if you have the combustion of methane, which is in natural gas, if your home is heated with fuel from PGW, okay, well, it has natural gas, which contains methane. So methane reacts with the oxygen in the air to produce carbon dioxide, 2 moles of water, and 802 kilojoules of heat energy. Okay, so the heat that is produced, that is released, is a product. Okay. Another example of an exothermic reaction would be a heat pack. Okay, now if I was in class, I would have the hot hands, and I would open up the hot hands package and I would pass it around the room, because the iron powder that's in the hot hands would start to react with the oxygen in the air and actually forms rust inside. But that's one of the main reactions in there, but we can't do that right now. But here I have another hot pack, okay, and this one works by, this has magnesium sulfate and water, so I don't know if you can hear the powder jiggling around in there, okay, and then there's a pouch in the middle, okay, an inner pouch which contains water, and when those two substances react with each other, it's an exothermic reaction, and heat is given off. You can see here on the package, it goes up to 50 degrees Celsius, okay, that's how temperature increases as a result of the heat that's released during that reaction. And so exothermic reaction gives off heat, heat is released, exile, exit, okay, and the heat quantity is written as a product. All right. Another way to represent this heat quantity is the change in enthalpy would be negative 802 kilojoules. Okay, change in heat enthalpy, I'm going to define that in a moment. Okay, you have a negative value because the heat is released. Okay, well, what about when you have a reaction that absorbs a heat quantity? We call that an endothermic reaction. If you think of the prefix endo, to endure, to take in. So an endothermic reaction, let's make that neat. Heat is absorbed. And the heat quantity is written as a reactant. And an example of a category of reactions that are tend to be endothermic are decomposition reactions. Let me give you an example. Okay. If we take 2 moles of water and 484 kilojoules of heat energy, we can break those 2 moles of water into hydrogen and oxygen molecules. To break those bonds requires the absorption of this heat quantity to give us the 2 products there. Okay. Notice that the heat is written as a reactant. Okay. And if we were to write that value, change in enthalpy, be positive 484 kilojoules. The positive value meaning that heat is absorbed. Okay. And an example of something of an endothermic reaction, you may have seen these types of cold packs in the store in the first aid section. These instant cold packs. So they usually contain ammonium nitrate. They can contain some other material as well. And again, you hear the crystals in there. And then you have an inner pouch which contains water. And if I were in front of you in class right now, I would demonstrate this. But if you break the inner pouch that contains the water and it mixes with the material inside, it gets cold instantly. Okay? Because it's absorbing in the heat from the surroundings. So an example would be, I'm trying to make sure I have room here, cold packs. Okay? Those instant cold packs. All right. So let me just define this term here. Okay, the Greek letter delta, it looks like a triangle, and the H, okay, which is for heat of reaction or enthalpy. Let's write that out. I've been mentioning it, but maybe for some of you it was the first time you've seen that. Some of you may remember seeing it in prior chem course, but let's just define what that is. That's the enthalpy, okay, or heat of reaction. It is designated as, okay, delta H, okay? And it's the amount of heat that is released or absorbed in a chemical reaction. And if you remember just from the two examples that I showed, for exothermic reactions, okay, the change in enthalpy, the heat of reaction, is negative. And for endothermic reactions, the heat of reaction, okay, or enthalpy, is positive. Okay. Now I mentioned this term calorimetry, okay, and the prefix calorimetry has the Latin calor meaning heat, okay. Calorimetry is the study of using calorimeters determine heat quantities for determining heats of reactions. So they're designed to measure the heats of reactions under conditions of either constant volume or constant pressure. Okay, so calorimetry is the study of using calorimeters, which determine heat quantities, for determining the heats of reactions. The calorimeters are designed to measure the heats of reactions under conditions of either constant volume or constant pressure. And one of the labs that was due to be done in lab was a calorimetry lab. And I'm sure your lab instructors will show you or send you a link for a video which shows this here. Okay.